Hello class and good morning or whatever the time of day it is kung anong oras ninyo pinanonood itong lecture video na ito. Today in this module, I will discussing about the overview of our organic reactions since our module 8 is all about the organic reactions. Okay, so the outline of our discussion for today, we will discuss the kinds of organic reactions, the mechanisms, steps and mechanisms, the two types of arrows in the radical substitution, polarizability, and generalized polar reactions, and using curved arrows in polar mechanisms. And we will not be discussing these slides, the topic about equilibrium rates and energy changes since it is discussed for your lecture topic, okay? The only scope is ang interest natin is the reactions and reaction mechanisms in our organic reactions, and we're done. Okay, so let's start. So why do we need to study this topic? Okay, to understand the organic of why, what, and how chemical reactions takes place in a biochemical processes and organic reactions. Okay, so there are four types of organic reactions. Kung sa may general chemistry nyo is natael about yung synthesis, there are also four types in a general chemistry na tayo nyo. We have synthesis or combination reaction, decomposition reaction, single displacement reaction, and double displacement reaction. So those are the four common types of reactions in your general chemistry. Sa may organic reactions natin, guys, there are also four common types of reaction that occurred in the organic reactions. Those are the addition reactions, elimination reactions, substitution reactions, and rearrangement reactions. And again, these are the common types of organic reactions that occurs in our organic chemistry. Marami tayong types of reactions na nagaganap. Okay, meron din na oxidation, nucleic acid substitution, but that's not scope of our discussion for today. We will discussing only the four types of organic reactions. Okay, so what are those? Okay, addition reactions when two molecules are combined. So this is analogous to our combination reaction in our general chemistry. But kung mapapansin niyo guys that our double bond ay naging single bond when two are formed. So may elimination reactions naman guys is nagkaroon analogous siya sa may decomposition reaction ng ating general chemistry. Ang usang with the action of acid catalyst, nag-decompose yung ating ethanol into ethylene or an alkene. Here, yung H2O ay nawala. And then, from single bond, nagkaroon tayo ng double bond. Next naman is substitution reaction. It is a molecular exchange where are the atoms of the molecules natin ay nag-exchange natin that participates in our chemical reactions here, where yung H ay napunta dito and yung Cl ay napunta dito to give two products. Sa ating rearrangement naman natin is only one molecule is involved, but the connectivity of the certain atom was rearranged and bonded to other atom here, such as the example of 1-butene naging 2-butene. Kung saan yung methyl, nagkaroon tayo ng methyl shift dito. Kung saan yung methyl na ito, from carbon number 1, ay napunta sa may carbon number 2. Carbon number 2 pa? 1. Oh, tama. Actually, 1, 2, 3. That's actually 2, carbon 3. Okay, but my point is, guys, is kung tayo, nag-occurs lamang. Nag-occur lamang sa isang molecule yung ating reactions natin with the help of our acid catalyst. So these are our four types of general reactions. But paano nangyayari yung mga yan? What are the mechanisms, or what is the mechanisms involved? What are the steps involved to form this product from this reactant? Ano yung nangyayari dito sa may gitna? What is the process? So dito papasok guys yung ating mechanisms natin. Kung i-compare natin siya sa may clock, yung second clock or yung second hand ng clock natin is yun yung general reactions. And then what happens behind the face of the clock? Yung mga certain natin, yun yung natin of what causes the movement. Yun yung mechanisms natin kung saan is a complex machine na nangyayari doon. So ayun, sa ating organic reactions, nakikita ninyo in transformation of a product from the reactant. But the mechanism describe the steps of behind the changes. Kung ano bang nangyari doon sa may reactant natin to form the product. So that's the house, that's the steps. This is just a surface. So we will go on deeper based on sa may mechanisms natin that the reactant lead to our product natin. So ano-ano ba yung steps sa ating reaction mechanism? the interest of our topic for today is about reaction mechanisms. Okay, our reaction mechanism is a step-by-step bond breaking and bond forming processes that involve in the organic reactions. Pwede siya mangyari individually or combination with other steps. Pero kapag two reactions ang nangyari, naganap, so occurs at the same time in one step, ang tawag doon is a concerted reactions. But remember guys that the reactions natin ay nangyari step by step and usually sila ay may sequence. Okay? Meron silang sequence for the bond forming and bond breaking of a covalent bond in our between molecules. Okay? So, there are ito ang typical examples ng ating mechanisms, guys. We have this single-headed arrow and double-headed arrow. So, ano-ano ba yung dalawang yan? What are those? Okay. Sa may kwan kasi natin, sa may reaction mechanisms natin, ang usually involved is yung ating mga arrows dito. Sir, ano po bang dinidepict ng arrow na yan? Dinidepict ng arrow na yan, guys, kung saan yung pag-flow ng mga molecules natin. Sila yung nagtuturo kung ano ba yung bond forming and kung ano ba yung bond na nag-break, kung ano yung bond na nag-form at kung ano yung bond na nag-break. So, arrow ang nagdidepict ng mga yan kung saan niya nilalagay. But we have different two types of arrow. We have symmetrical and unsymmetrical. Symmetrical is a homolytic. When you say homolytic, the electrons are equally distributed between two atoms here. Ayan, no? Equally distributed. Ayan. Kita ninyo, we have two electrons. Pero sa may unsymmetrical or heterolytic natin is kapag double-headed arrow, ito yung single-headed arrow, ito yung double-headed arrow sa ating unsymmetrical, is yung electrons natin ay nagmo-move sa isang directions. Isa lang. Ayun, no? Yung dalawa ay nag-move sa isa, such as this letter B here. Kaya siya nag-generate ng negative charge. This one here is positive charge. Because electron is negatively charged. And kapag nawala ng electron sa A natin, magiging positive charge siya. Whereas here in our symmetrical or homolytic cleavage is equally distributed. So neutral magiging charge nila kasi they both contain an electron. And we have, as pa natin, sa sinabi ko kanina, we have two types. Okay, this one is bond breaking process that happens in a homolytic cleavage and homolytic bond breaking, or this one here is a heterolytic. And then meron yung bond forming na homolytic and heterolytic na kung saan, okay, the electrons are going to move to bond with our cation here or whatever it is. Basta positively charged organic yan. And then here, ito, equally sila, both silang mag-move, pero ito ay silang mag-move. Okay? So, unahin natin yung ating single-headed arrow. Okay, the curved arrows indicate a breaking and forming of bonds. Arrowheads with a half head indicate a homolytic step, whereas yung double-headed arrow with a complete head indicate a heterolytic or heterogenic steps called polar processes and radical processes. So, ayan yung mga yon. So, sa ating radical reactions, guys, which involves a single-headed arrow or half-head arrow, is ito, ang common na nangyayari doon is a radical reaction. And usually, ang radical reactions natin, our single-headed arrow, ay nangyayari lamang sa ating alkane with the presence of light. Since alkane is an unreacted functional group in our families of carbon compounds here. Now, ito, kung mapapansin niyo guys, ayun, no, there is a movement of electron here. Ayun, no, isang electron yung nag-move dun sa may A. Ayan, no, it is a bond-forming and bond-breaking process of a radical reaction. Pag radical reaction, meron tayong unpaired electron and the charge is usually neutral. Okay, the common example of this is for the reaction of our chlorine atom. This is actually a diatomic atom here. Pero ito ay na-cleavage na siya. So it is a chlorine radical and a methane. So it involves three steps kapag sa ating radical substitution. We have initiation, propagation, and termination. Kapag initiation, guys, it is a homolytic formation between two unreactive species here. So this is an initiation here. Ayan. And then, kapag naman nagkaroon tayo ng propagation, reaction with two molecules to generate a radical, kung saan yung chlorine atom natin ay nag-react sa ating methyl radical na nanggaling dito sa ating initiation step. Ayan. And then sa ating termination, kasi meron tayong mga generate na radicals yan, it is just a combination of two radical molecule to form a bond. Nagkaroon sila ng bonding. So, ganon. It is a single-headed arrow and isang electrons lamang nag-move. Okay. So, next naman sa reactions natin, guys. Okay, remember, radical reactions or radical substitution always usually occurs in our alkane. Okay? Sa ating polar reactions naman din, it is a asymmetrical electron distribution na dito na natin i-consider yung difference in their electronegativities. This causes a partially positive negative charge and partially positively charged. And the more electronegative atom has the greater electron density. Elements such as ONFCl more electronegative than carbon. So, ano ba yung sinasabi ko dito? Since our subject is organic chemistry, ang interest natin is yung carbon with its corresponding bonded heteroatoms here. So, usually, itong mga to, ay mga itong mapapansin ninyo, guys, is ng mga elements na present dito at sa carbon is more electronegative than carbon na nakabandon. Siyempre, i-accept natin hydrogen. You all know that the carbon is more electronegative than hydrogen. I-exclude natin mga itong mga to. So, they will contain a partially negatively charged and partially positively charged. Bakit kaya ganun? Kasi nga, oxygen is more electronegative than carbon natin. Kaya siya nag-generate ng ganyan charge. And that will relates to our polarizability. When we say polarizability, okay, ito ang mangyayari doon. Magkakaroon tayo sa ating electrostatic potential map here is ito yung electron-rich areas natin. Na kung saan, tandaan niyo guys, the electron always attack the positively negatively charged. Ganito yung usually reaction na nagaganap. Itong electron-rich region na ito is always, ito yung nag-attack lagi. Ito yung nag-distribute ng electrons o siya yung kukuha ng electrons natin from the atoms. Siya attack sa atoms natin. Okay, ang sinasabi ko dito guys is dito kasi mag-a-arise yung term na nucleophile and electrophile. Electrophile is an electron-poor species while nucleophile is an electron-rich species. Electrophile is a Lewis acid, donates hydrogen atom, and nucleophile is a Lewis base, accepts hydrogen atom. Okay, paano ba yan? So we have this nucleophile here, an electron-rich molecule attacks the electrophile. Tandaan niyo guys the curved arrows, yung electrons lagi ang nag-move sa ating reaction mechanism. If you could recall dun sa may ating esterification that nangyari sa ating experiment number 6. Okay? The nucleophile always attack the electrophile, not the other way around. Kasi nga, as an example illustrated here, this one here is the nucleophile, this one is electrophile. Sir, bakit po naging electrophile yung ating hydrogen? Kasi nga, oxygen is more electronegative than hydrogen. Sir, saan po nag-arise itong electrophile na ito? Kasi nga, kung mapapansin niyo guys, among this molecule, the oxygen is the most electronegative atom present in this compound here sa ating methanol. Okay. Ngayon, in-attack nyo ito, since this one here is an electrophile, kaya nag-form ng ganitong compound. Ayan. So, ganun-ganun yon. So, another example here, occurs here. Ayan. So, nangyari. So, ito, this one here is the electron-rich areas of some specific compounds. Ayan. Ito yung mga electron-rich nila. Sila ngayon yung a-attack dito sa may mga electron-poor region ng ating compounds natin. So, this red will attack here, dito. And then this red will attack to the blue region here. And then this red will attack to the blue region dito sa mga ito. So, ayun yung mga electron-rich area or region and electron-poor area na illustrate sa ating electrostatic potential. Okay? So, the common example nito, guys, is this is just an example of a polar reactions. The addition of hydrobromic acid to ethylene. So, paano ba nangyari yan, sir? Sir, wala naman po ditong electron-rich area, sir. Kung papansin niyo po, double bond lamang ito. Wala naman pong electronegative species dito. Pero bakit po nagkaroon ng reactions between hydrobromic acid? Although, sir, ito naman ay electrophile. Kasi nga, guys, the double bond is also an nucleophile here that is capable of attacking magkakaroon tayo ng attack dito sa ating hydrogen here to form this bromide. So again, what is this reaction? It is an addition reaction. Kasi nga, formation of two reactant to form one product. Okay, this is just the reaction mechanism. The double bond will attack the electron pore area or the electrophile to form ABr. So magkakaroon tayo ng ganito. Mag-generate tayo ngayon ng partially positively charged. Na kung saan yung ating natin from the hydrobromic acid natin, meron na tayong nucleophilic region dito kasi negatively charged na siya. And sa may carbon natin, nag-generate tayo ng positively charged or carbocation. Kasi nga, kaya ganon, is due to the resonance structure ng ating carbon na na-discuss naman sa ating module 2 ng ating discussion. So the nucleophile is now a nucleophile. The bromides ng nucleophile will attack the electron pore region of our ethylene. So ganito na mangyayari to form a bromide. Okay. So this one here, ayan. Ito, pinapakita lang dito. Okay. The curved arrows are a way to keep track of changes in bonding in polar reactions. So siya yung nagtatrack for the bond breaking and forming reactions. Electrons always move in pairs. Kapag hindi pair, kapag isa lang yung mag-move, that is a single-headed arrow or homolytic cleavage yun. Okay? And then magkakaroon tayo ng charge during the reaction. Okay? And then so on and so forth. So ito yung two types of our polar reactions here. We have the nucleophile and the electrophile. Negatively charged, positively charged. So attack siya dito to form this compound here to form a neutron. Pero dito naman, kung mapapansin niyo, yung double bond din natin is capable of attacking. But, mag-generate siya ng positively charged. Which is then, eventually, itong bromide na ito is attack dito sa positively charged para magkaroon tayo ng bonding. Okay? So ito, another example here. Ayan. Okay? Take note of the octet rule, guys, ha? So, doon pa rin papasok yung mga ganyang bagay. Dito papasok yung mga foundations ng organic chemistry. The octet rule and the resonance structure. So this is a typical reactions. Okay? And don't worry guys, magbibigay ako ng examples sa ating next lecture for the reaction mechanisms of our laboratory 7 to 9. Okay? So this is the equilibria, rates, and energy changes. And this is not the scope of our discussion for today. So, ayan, that ends our discussion and I hope you learned something, guys. Kung meron kayong questions, kindly message me through Messenger or Gmail. I think Messenger na lang kasi hindi ako nag-check frequently ng Gmail ko. Okay. So, thank you guys for listening and have a good day.